Experiments with clean, disease-free ginger seed were conducted at the University of Hawaii Waiakea Agricultural Research Station near Hilo, Hawaii. The goal of this research was to develop growing methods which could consistently produce pathogen-free ginger seed for planting the next crop. Producing clean ginger seed requires a pathogen-free plant growth medium. This medium consists of sunshine No. 1 mix, perlite, and core in a 1:1:1 volumetric ratio. The original ginger seed batch was produced 8 years previously by a tissue culture laboratory. The plantlets were grown out and selected for desirable growing characteristics, and their progeny were maintained by clean hydroponic culture methods to the present day. The growth medium is thoroughly mixed. We will first discuss a sub-irrigated pot method. A 7-gallon pot is filled with growth medium. An inverted 3-liter pot is placed within the larger pot to conserve growth medium and to provide added aeration for the roots. This growth medium is filled to slightly above the top of the inverted pot. 3 2-ounce ginger seed pieces are planted in each pot. These are clean, disease-free seed pieces which were grown in a pathogen-free hydroponic culture method last year. The pot is filled with growing medium. Pots are placed on a bench in a greenhouse. After 3 to 4 weeks, the ginger seed pieces begin to sprout. By 6 weeks after planting, 6 to 12-inch tall ginger shoots appear. This ginger is transported to elevated growing tanks protected by simple rain shelters, as rain dilutes the nutrient solution and thereby retards growth of the ginger. The rain shelter should be located away from a commercial ginger production area. Blowing dust should be minimized. A 5-foot length of rebar is driven into the ground and fitted into a 10-foot length of 1-inch PVC which is arched over the tank. A reinforced clear plastic cover is placed over the arches. The pots are moved into polyethylene-lined growing tanks. Tanks are 2 feet wide by 8 feet long and 5.5 inches high. In this case, pots rest on the bottom of the tank and are sub-irrigated throughout the growing season with nutrient solution. Another growing method was tested in which the growing pot was elevated with a 2-inch spacer and placed into another pot resting on the tank floor. The growing tanks are constantly supplied with nutrient solution that flows by gravity from a 300-gallon tank. The stock solutions are stirred before adding to the water. Nutrient solution is prepared by adding 2 fertilizer stock solutions to the 300-gallon tank of water. Nutrient solution flows by gravity to a sump assembly that contains a float valve, which maintains a 2-inch depth of nutrient solution in the growing tank. The concentration of the nutrient solution is measured with an EC meter that measures electrical conductivity of the fertilizer ions in solution. The target is to maintain a nutrient solution strength in the range of 1.5 to 2.0 millisiemens, which is abbreviated to MS. In this case, the meter reads between 1.6 and 1.8 MS. Ginger grows vigorously as the season progresses. The expanding rhizomes produce powerful forces which cause the plastic pots to split. For the single pot method, a pot is removed from the tank. Notice the roots emerging from the openings in the pot and that the pot has burst due to the vigorous rhizome growth. For the double pot method, the growing pot is removed. There is vigorous root growth emerging from the pot. The foliage is cut about 6 inches above the pot's surface. The pots are removed from the tank and placed in a truck. The pots are hauled away and placed on a bench in a heavily shaded greenhouse. After about 3 weeks of drying, the ginger is removed from the greenhouse and taken to the washing station. The dried foliage stubble is removed from the pot. Water is sprinkled on the pot to make it easier to remove the ginger. The pot is tipped over and emptied. The inverted 3-liter pot conserved the growth medium while adding valuable aeration to the roots. The growing medium is broken apart. Rhizomes are sprayed with water and cleaned. The mass of rhizomes is cut into smaller hands. Roots are cut off and receive a final rinse. The rhizomes are placed in a nursery tray on a greenhouse bench to dry for several days to prepare them for distribution to growers as seed for their next crop. Growing medium is washed from the expanded metal bench and captured for reuse for other nursery applications. The average yield from single pots was 10.8 pounds per pot. Yields were reduced when the rain shelters were shaded. The average yield from the double pot method was 9.1 pounds per pot. Although the double pot method has the potential to produce a higher yield due to the increased root aeration, in actual practice it was difficult to maintain an optimum nutrient solution level in the growing tank, and this caused greater variability among pots. Better quality ginger was grown in the 7-gallon pots than the 5-gallon pots. We will now discuss a second ginger seed growing method. Ginger is grown in roll-out tanks which consisted of 4 feet wide heavy-duty plastic sheets that are rolled out over a level greenhouse bed and formed into channels. Each channel is filled with 8-foot-long growing slings that are 9 inches wide by 6 inches high and made of heavy-duty plastic sheeting with slits on the bottom. Or they may be constructed from synthetic weed control fabric. Inverted nursery trays were placed on the bottom of the channel to support the slings. Cinder blocks support the outside of the channel. The slings were filled with pathogen-free growth medium consisting of Sunshine No. 1 mix, perlite, and core in a 1:1:1 volumetric ratio. This float valve maintains 2 inches of nutrient solution in the tank. The nutrient solution is routed to a drip irrigation tube which rests on the surface of the growth medium. Thus, the plants are top-watered as well as sub-irrigated. A liquid level indicator is placed in each tank to alert the grower in case the irrigation system fails. 2 fertilizer stock solutions are prepared. They are injected into the irrigation water with water-powered fertilizer injectors and delivered to the float valve and then to the drip irrigation tube which waters the ginger. The nutrient solution strength is monitored with an electrical conductivity meter. Ginger grows vigorously as the season progresses. Lift the sling out of the tank by first passing a pipe through the loops of the sling. Then the sling with growing medium and plants is lifted out of the tank. This gives a good view of the roots passing through the slits in the sling. Notice that the roots pass through the inverted trays, causing them to cling to the bottom of the sling. There is about 1 1/2 inches of nutrient solution in the tank at this time to constantly sub-irrigate the ginger. In December, the irrigation is shut off and the plants are topped after the nutrient solution level has receded. The remaining foliage has dried and is removed about 3 weeks later. The drip irrigation tubing is removed from the tank and pipes are placed through the loops of the sling. The sling is lifted from the tank. Some of the inverted trays are loosely attached to the sling by the dried roots. The rhizomes and growth medium are emptied from the sling onto the bench simply by tipping the sling over. The growing medium is washed from the ginger. Approximately 32 pounds of cleaned rhizomes were harvested from an 8-foot sling. These growing methods produce clean ginger rhizomes which are free of bacterial wilt. They will be cut into approximately 2-ounce seed pieces and planted several months later during the upcoming ginger crop.